So, today we're going to dive into something called OpenClaw. It's a really powerful memory architecture that completely reframes how we should be thinking about AI development. The big idea here is that building a great assistant isn't just a model problem, it's really an infrastructure problem.
You've probably had this happen, right? You have an amazing, detailed conversation with an AI. You teach it all this stuff, and then the next day, it has no idea who you are. Well, that's because you've run smack into the core problem. Large language models are fundamentally stateless. They just don't have built-in memory, and that is the biggest hurdle we face in building a truly helpful long-term assistant. So here's our game plan. We'll start by really unpacking that stateless problem. Then we'll explore OpenClaw's radically simple philosophy. From there, we'll get into the weeds of its three-tier memory system, its smart retrieval engine, and see why its local-first design is such a game changer for developers. And finally, we'll zoom out and look at the future of this kind of infrastructure. To put it as simply as possible, an LLM on its own is basically like a person with severe short-term memory loss. It's brilliant at processing what you're saying right now, in this moment. But as soon as that conversation ends, poof, the context is just gone. Every single time you start a new chat, you are starting from a completely blank slate.
And this is where OpenClaw just completely flips the script. Instead of reaching for some complex, heavy-duty database, it asks a really simple question. What if the source of truth for an AI's memory was just simple, human-readable files? This reframes the entire challenge. It's not a data warehousing problem anymore. It's an operating system problem.
Now, this philosophy is part of a much bigger picture. The memory system we're talking about is just one crucial piece of OpenClaw's hub-and-spoke architecture. You've got this central gateway that acts as the control plane. It's handling all the sessions, the tools, access control, all that stuff. And then you have the agent runtime, which is actually doing the AI work. The memory system just plugs right into this framework. Okay, let's get into the heart of the design, the three-tier memory system. And the core idea here is brilliantly simple. Not all memories are created equal. Some things you need to know all the time, some things you only need to know for a day or two, and other things you just need to look up occasionally. So why not organize the AI's memory exactly like that? So Tier 1 is the foundation. It's literally just a single markdown file called MEMORY.md. Think of this as the essential briefing you'd give a new colleague on their very first day. It's got your core preferences, key facts, major decisions, the absolute need-to-know stuff. And because it loads with every single conversation, it's kept concise, which means it has a really low token cost. All right, Tier 2 is what gives the AI a sense of time. It's basically a collection of daily note files. And by default, OpenClaw automatically loads today's note and yesterday's note. This is super clever because it recognizes that most of our follow-up conversations happen within a 24 to 48-hour window. So this gives the AI crucial, recent context without having to load your entire life story. And finally, we have Tier 3, which is the long-term archive. This is your deep knowledge base, all neatly organized into topic folders, projects, people, important meeting notes, whatever you want. But here's the critical part. These files are not loaded by default. They are only searched and pulled into context when the conversation actually needs them, which makes the whole system incredibly cost-efficient. You only pay for what you retrieve. Let's see how this all works together in practice. So, a new conversation starts. Right away, Tiers 1 and 2 are automatically loaded. That's about 1,000 tokens, give or take. Then, you ask a specific question, like, how's the resume app deploy going? The system then searches Tier 3, finds only the relevant file, projects/resumeapp.md, and loads that into context. And the result? Your total context is just around 1,300 tokens, and you've completely avoided loading the massive 15,000-plus token memory base. Super efficient. Okay, a tiered system is great, but it really hinges on two things, right? First, you have to be able to find the right information in Tier 3. And second, you have to manage what happens when a conversation gets really long and you start hitting context limits. This is where OpenClaw's secret sauce comes in. It's smart retrieval and retention systems. The big challenge with search is that you've basically got two main approaches, and honestly, both of them have some pretty major flaws on their own. On the one hand, you have vector search. It is fantastic for understanding the general vibe of a query, the semantic meaning, but it can be absolutely terrible at finding exact keywords. And on the other hand, you have keyword search, which is the exact opposite. It's perfect for exact recall, but it has zero understanding of context or synonyms. So OpenClaw's solution is just to use both. It's a hybrid approach that fuses their scores together. As you can see here, it combines the vector search results with the keyword search results. But the really crucial detail is the weighting. By default, it actually favors the keyword results just a little bit. And that's because for an assistant, being able to recall an exact fact, like a port number or a specific person's name, is often way more important than just getting the general semantic vibe right.
Okay, so search is solved. But here's the other big elephant in the room that most systems just kind of ignore. What happens when a really long conversation finally hits the model's context limit? You have to start dropping old messages to make room. But what if those messages contain important new information that hasn't been saved to your memory files yet? You're about to lose it forever.
This might be the most elegant piece of engineering in the entire system. It's called the automatic memory flush. When the context window gets about 80% full, OpenClaw triggers a silent, invisible prompt in the background. It basically tells the model, hey, we're about to run out of space, do me a favor and review this conversation one last time and save anything important to the memory files. The model does its thing, updates the files, and only then are the older messages safely compacted or dropped. The user never even sees it happen. It's genius.
So, what does all of this actually mean for the people building with this tech? Well, all these smart design choices add up to some huge advantages for developers, and it's all centered on this principle of being local first.
Let's just compare this directly with the old way of doing things. With a traditional database model, you need server infrastructure. You're constantly wrestling with complex schemas, and just trying to inspect or back up your data is a whole production. With OpenClaw's file model, you need zero external infrastructure. It is just human-readable markdown files. That makes it incredibly simple to version control with Git, to back up, and most importantly, to debug. You can literally just open a text file and see exactly what the AI knows. I mean, think about that for a second. Your entire, powerful, multi-tiered memory system, with its fancy hybrid search engine, is nothing more than a folder of text files and a single SQLite file for the search indexes. You can copy it, you can zip it up and email it to a colleague, you can check it into Git. The portability is completely off the charts.
And this whole approach really points to a broader trend in the industry. The future of truly capable AI assistants isn't just about making bigger and bigger models, it's about building smarter and more robust infrastructure around them. So let's take a quick look at where all of this is heading. The OpenClaw ecosystem has this optional plugin called MemOS, and you can think of it as a specialized memory operating system. It takes all the core concepts we just talked about and just supercharges them. It adds things like graph-based storage, which is great for understanding complex relationships between memories. It can handle multiple data types like images, not just text. And crucially, it provides isolated memory for different AI agents so they don't step on each other's toes. Now, let's be clear, this is not a completely solved problem. There are still some really big challenges out there. There's no standard schema for how to structure these memory files. There's no built-in versioning or changelog to see how the AI's memory evolves over time. And there's no easy way to sync memory across all your devices without using some other cloud service. These are really the next frontiers for this technology. So if you take just one thing away from all of this, it should be this really powerful pattern that's starting to emerge across the industry. It's this combination of three things. Simple, human-readable markdown files is the ultimate source of truth. A smart retrieval layer on top to find what's relevant, and then using the LLM itself to curate and maintain its own memory. And that really leaves us with this final thought. A model, no matter how huge or powerful it is just a brain. It's an incredible pattern matcher. But a brain without memory, without context, without a sense of time, it can't truly be an assistant. It's the operating system layer, the memory, the tools, the session handling. That's what turns a raw brain into something that's actually truly helpful.
If you found this helpful, hit subscribe and the bell so you never miss a video.